on the page that says worksheet 2.1. Still with me? All right, worksheet 2.1. All right. So did I work number 5 or no?
No.
No? Okay. So it says let's C at x plus 250. So we have C at x. We have 5x plus 250. And then R at x is 27x. So write the profit function. So the profit function, so for letter A, the profit function, P at x, is going to be the revenue minus the cost. Okay, so I'm going to go 27x minus, and the big error that people will make this mistake is you want to put that whole thing in parentheses. So when you distribute your parentheses or your negative over the parentheses, you get to there, which then gives you 22x minus 250. That is your profit equation. Okay? So notice, because I'm adding two functions together, the slopes have actually changed. So what is the slope in this problem? So the slope in this problem is now 22, which basically means that so you're making $22 for each. Is it what?
I think so too.
25 minus 20, 27 minus 5.
Oh.
So you're making $22 for each one item that you produce or something like that. And then it says, what is the marginal profit? The marginal profit is then 22 as well. It's whatever the slope of the profit equation would have been. And D, interpret the marginal profit. They all mean the same thing. B and D are about the same answers. Okay. Questions there?
Can you explain how the slope is 22 again? What's the rule you just said?
So I subtracted R at x minus C at x. So the slope's actually changed.
But why is that the slope though?
Because it's right before the x on a linear equation. Y equals mx plus b. You know this equation?
Yeah.
So it's whatever the x value is. All right. Problem number 6 says a company is charting its profits, notices that there's a relationship between the number of units sold X and the profit P is linear. If 200 units sold results in 310. If 250 units are sold, the results are 6,000. Write the profit function based on that. All right. So for problem number 6, they give you 2 points. 200 gets you 3,100, and 250 gets you 6,000. Okay. So you could say, let's find the slope. And then we can use point slope. And then you can convert this into y equals mx plus b. But what fun is that when we have decimals? All right, so let's take a look at, make sure we make this work with decimals. I have 2 points. I have 200, 3,100, 250, 6,000. If you jump onto decimals, which is somewhere around here, go to graphing calculator. And again, I'm not expecting you to be pros at this. I'm just showing you how this works. So you have the table. So I'm going to have 200 and then 3,100. And then I have 250. And I have 6,000. And if you hit the little magnifying glass, it gives you those 2 dots that are right there. And you're like, Well, that's great, Stirrup. I have 2 dots on a thing that doesn't mean anything. Yeah, so on Desmos, if you go Y1, because our Y value is Y1, and you use that little tilde, okay, and you can find that on the screen. The tilde tells Desmos, hey, we need to make an equation. Okay, in this case, we're going to do y equals mx plus b, but we're going to change equals to tilde, y to y1, x to x1. So I'm going to go mx1 plus b, and that's my linear equation. So it gives me my slope right there is 58, and it gives me my y-intercept is negative 8,500. Okay? And then find the marginal profit. Write a profit and find the marginal profit. So marginal profit was what? What did we say marginal profit was? I gotta look in the book because I don't remember off the top of my head. Sorry. I'm dumb. I want to find out here in a second. All right. Says the slope of the profit function represents the rate of change in profit with respect to the number of units produced. This is called the marginal profit. So what's my slope of this? 58. My marginal profit is 58. Okay? Just means for each item you make an additional 5,800. Is there a break-even point that you can find? Yeah. Then you get to number 7. It says a widget manufacturer incurs costs for widgets according to this equation. Okay. Get away from that. Pull this off again. All right. So for problem number 7, they tell us we have a cost equation of this. 1650. And then they tell us we have a revenue equation of this, which is 85x. So if we want to make manufactures that, if revenue function is that, how many widgets must be sold to break even? Oh, we got to go back to Desmos. Graph these 2 lines. So let's clear that, clear that. So rather than using C of x, I'm going to go y equals 35x plus 1650. And then y equals, rather than r to x, 85x. And it looks like these are going to intersect each other. What do you think? Nice thing with Desmos is you click the little button. Oops. So once you make 33 items, you are breaking even at 33 items. If you make 34 items, you're making profit. If you make less than 33 items, you're taking a loss. Okay?
So if you make 33 items, that's the break even.
Break even means the amount of money you spent versus the amount of money you brought in was 0. All right. We good so far? And then number 8 says the manufacturer sells widgets for $12 per unit. Fixed costs are $1,600, and the variable costs are $8 per unit. Write an equation of the cost and revenue function. Find the break-even point. Okay. So problem number 8, they said manufacturer sells widgets, $12 per item. So Rx equals 12x. And then the fixed costs are $1,600 with variable costs being $8 per unit. So that's our cost. All right. So if we want to find the break-even point, I'm going to graph both those lines. Again, using Desmos because I like Desmos. So we got 12x, and we got 8x plus what?
1,600.
1,600. Thank you. All right. So kind of zoom it out. It appears that they are crossing each other somewhere in here. So it looks like once we get to manufacturing or selling 400 items, that's our break-even point. If we sell more than 400, we're making profit. We sell less than 400, we're taking a loss. And that's kind of how it works. Woo, baby.
This must make things really easy.
That's my point. So I realized two things are going to show up at school every day or with you at all times. Your head's going to be on top of your head, on top of your shoulders, I guess. And your phone's going to be with you.
Oh, yeah.
Now, it might not be charged, but it'll be with you. So don't worry, I got this external battery pack I can charge it with. Yep. All right, and then number 9 says the company manufactures and sells widgets. The selling price is $54.90 per widget. The total cost function is linear, and the cost amount of $50,000 for 2,000 widgets and $32,000 for 800 widgets. All right. So for problem number 9, we have y equals 5490. This is our revenue, R at X. And then they gave us these 2 points. So friends, how am I telling you to do these 2 points? Desmos all day long. But you know what? They kind of said it backwards, so you want this to be, I wrote it backwards. So 2,000 comma 50, or 2,000 comma 50,000, and 800 for $32,120. All right, that definitely goes into Desmos. And again, Desmos, try to see if you can make this work. It's not hard. You just, first thing you do is you hit the plus button, then you hit table, and then I'm going to plug in 2,000 comma 50,000, and then I'm going to plug in 800, and that's going to give me 32,120. And then Desmos again, y equals mx plus b, but plug in y1, use tilde, x1 plus b. So there's our linear equation. It says write the equation for the revenue. Okay, so hang on. I'm gonna write y equals. I'm gonna write this down here, and then I'll show it to Desmos. So my points here are going to give me y equals 14.9 plus 20,200. That's our cost. And our revenue is going to be 5490. All right, so I'll go back to this so you can have the answers. So by using this equation, this is going to be my cost equation that it creates, which is going to be y equals 14.9x plus 20,200. And then my revenue, R at X, is equal to 5490 X. So those are my 2 equations. So you have that and that. So cost and revenue. And then find the break-even point. Going back to our buddy. Hey, when are you guys texting me? My phone just texted. Let's get rid of that, get rid of that. And then y equals 5490. All right. That's where those 2 intersect each other. Click it. So once you have sold 505 items, that's your break even. If you've sold 506, you will make a profit. If you sell 504, You are not making a profit. All right.
Can you go back to the other screen?
Yeah, of course. All right. So, my friends, I don't want to create a video for you on 2.2 because I think you're going to lose a little bit out of it. So, between today and tomorrow, we're going to go back a couple pages in the book. Every one of these things can be done using Desmos and then just sketch the graph what it looks like. So I'll just say by Friday, which is really Monday because we have credit card stuff we're talking about on Friday. I'm going to assign this graphing review 1, 2, and 3, which is the previous pages. And there are answers that are there. 1, 2, and 3. Yeah, that should be perfect. So I honestly use Desmos to create it. Play around with Desmos. The nice thing with Desmos is if it's like number 5 on review 1, where it says 3x minus 4y equals 12, you can do that. You could plug that directly into Desmos just like that. You don't have to make it y equals mx plus b. So that's what your assignment. So basically tomorrow, get that done during class, and then and that's what you'll work on with the sub. But rest of the period's yours to either start what I just said. Does everyone know where graphing review 1, 2, and 3 is? Does that make sense? It's in the book. Looks like there's the answers for review 1 that are there, and 2 and 3. They do have some mins and maxes they look for, any asymptotes, stuff like that. If you get stuck on something, we could totally, go over those questions with you. But I just wanted to kind of give that to you guys for something to do tomorrow. Deal? Rest